Okay, we're going to find the exact values of cosine theta and sine theta given that tan theta is 5 over 2 and cosine of theta is negative. Okay, so I'm going to draw my triangle like so. It's going to be a -2 and a -5 since cosine is going to be negative. That also means sine is going to be -2. Okay, and so I'm going to pick my theta to be here. Okay, perfect. So now we need to find cosine of theta and sine of theta, and to do that I'm going to need the hypotenuse. So how can I find the hypotenuse of a right triangle? Well, it's just going to be the square root of my distances squared and added together. So that comes from, we know a squared plus b squared equals c squared. So c squared better equal -2 squared plus -5 squared. So c is going to be equal to the square root of 29, 25 plus 4. Okay, beautiful. So now we have our triangle. Now we can make values for cosine and sine. So cosine of theta, remember that cosine of theta is adjacent over hypotenuse, so cosine of theta is going to be -2 over my hypotenuse, which is 29, root 29, and then sine of theta is going to be opposite over my hypotenuse, so -5 over square root 29. Okay. Okay, so we have a line passing through the origin at the point A, comma 10, and forms an angle pi over 8 with the x-axis. Okay, so we'll go ahead and draw that picture if this is my origin. Then I have a line that passes through the point A, comma 10. So that makes a little triangle right here. Okay, beautiful. So then I know that my height right here has to be 10 because that's my y-coordinate of the point P, and I want to know about this distance A right here. Okay, so we also know that the line P forms an angle of pi over 8. So I think we have enough information to use some trig here. So I think we can say that tangent of pi over 8, that's going to equal my opposite over my adjacent side, so that should equal 10 over A. If we go ahead and solve this for A, we should get that A is equal to 10 over tangent of pi over 8, and that should give about 24.1. Okay, for number 15, we know that sine of t equals x over x plus 5, and we need to find the other 5 trigonometric functions. Okay, so if sine of t is x over x plus 5, if I pick my theta to be right here, then I know that the opposite side over my hypotenuse is equal to x over x plus 5. So this side should be x, and this side should be x plus 5. So now I want to know about this side right here. And so from the Pythagorean theorem, I should know that x squared plus my b squared, the length that I don't know, should equal x plus 5 squared. So b squared should equal 10x plus 25. So b equals the square root of 10x plus 25. Okay, so now we can label that side on our triangle 10x plus 25, and we can start to make our other ratios. So cosine of theta is going to be adjacent over hypotenuse, so that should be that 10x plus 25 over x plus 5. Secant should just be 1 over cosine, so secant of theta should just be x plus 5 over square root of 10x plus 25. Okay, and then we know that sine, we know what sine is, and we know that cosecant should just be 1 over sine. So in this case, that should be just x plus 5 over x. Okay, great. What else do we have left? We have tangent and cotangent. So tangent of theta is going to be my opposite over my adjacent side, so it should be x over 10x plus 25. And then for cotangent, it's just 1 over tangent. So I can simply flip my tangent fraction. So then we get that cotangent is the square root of 10x plus 25 all over x. Okay, perfect. All right, so we have Josie who's walking 100 feet away from a light post. So if we kind of draw the picture, maybe here's the light post. And then Josie's over here, she walked 100 feet away. So we know that this is 100. And then she measured the angle of elevation from the ground at her feet to the light, and that was 20 degrees. Excuse my poor drawing. Okay, and we need to figure out how tall the light post is, so let me maybe call this height x. Okay, so we stare at this picture and we see if we can find any trigonometric functions or ratios that describe what's going on, and I think we do. Tangent involves our opposite and our adjacent side. So let's use tangent of 20 degrees. That better be equal to our opposite side over our adjacent side. So then we solve and we get that that distance better be 100 times tangent of 20 degrees, which when you punch that into your calculator, making sure you're in degree mode, that should give you 36.39 or 36.4, and that'll be in feet. Okay, now we have this water slide, and we want to know how long the water slide is. So if I call this distance right here y, and maybe this distance right here x, then I just need to find these two side lengths. And I know that this little distance right here is 8, and I know that this distance right here is 15. Okay, great. So if I redraw my other triangles, so maybe I have y, and this is 12 degrees, and this is 8, and then for my x triangle, I have x and 15 and 29 degrees. So for this equation, or for this triangle, I think the equation that we'll need is going to be sine, because we have an opposite side and the hypotenuse, so I think we can say sine of 12 degrees is going to equal my opposite over my hypotenuse. And then we have the same situation with this x triangle, so similarly sine of 29 degrees is going to equal 15 over x. Okay, so then if we solve both of these for their respective variables, we'll get that y should be equal to 8 over sine of 12 degrees, and x should be equal to 15 over sine of 29 degrees. Okay, and then when we punch that into our calculator, we should get that y is equal to 38.48 and x is approximately equal to 30.94. So then we know that the length of the water slide should just be x plus y. So then that should give us 69.4 feet, which is equivalent to 69 feet if we're going to round. Okay, next we have problem 18, and we can see that we have two triangles here, and we're given two angles of elevation, and we need to find this height b here. The first thing that I notice is that these two triangles share this bottom side here, so I think our first step will probably be to find that length, and maybe we'll call that length x. This length right here. Okay, perfect. So then if we redraw our triangles, we have 150x, and then it tells us that the angle of elevation is 22 degrees. And so then we can set up a tangent equation. We can say tangent of 22 degrees equals my opposite over my adjacent side, so that should equal 150 over x. And then we can solve for x and get that it should be exactly equal to 150 over tangent of 22 degrees, or approximately equal to 371.263 feet. Okay, great. Now that we know that bottom distance, now we can draw our other triangle that includes the building B. So this will be that 371.263. We're trying to find this height b, and we're told that this angle of elevation is 43 degrees. Okay, so then I think we'll set up another tangent equation. We'll have tangent of 43 degrees equals that opposite side b, over my adjacent side, 371.263. So then B should equal the tangent of 43 degrees times this 371.263, and that should give me approximately 346.2 feet. Okay, so now we have number 19, and we're trying to find how far away Cassie is standing from the base of the pyramid. And so I see two right triangles that we can use. I see the pyramid and then the larger outside triangle. So let's maybe call this leg y of the smaller triangle, and then maybe this whole distance is going to be L. Okay, that'll come in handy later. So then if we draw our triangle, we have 40 degrees and 300 and our unknown distance y. So we can set up a tangent equation, and we can say that tangent of 40 degrees equals my opposite over my adjacent side, so 300 over y. And then we can solve for y to find that it is 300 over tangent of 40 degrees, or approximately equal to 357.526. Okay, great. Now let's look at our larger triangle, the one that contains the pyramid. We know that this bottom distance is L, that's what we named it, and this height here will be 300, and we're given this angle to be 28 degrees. So similarly, I think we'll set up a tangent equation, and we'll get that the tangent of 28 degrees is equivalent to this 300 over L. We can solve this equation to find that L is equal to 300 over tangent of 28 degrees, or approximately equal to 564.218. Okay, so then if we look back at our original picture, we have that this length should be equal to the length of x plus the length of y. And so I know L, I know y, so I can solve for x. L minus y equals x. So then we know that our 564.218 minus our 357.526 should give us that distance x. And that is approximately equal to 206.69. And if we round up to the nearest foot, it'll give us 207 feet. Okay, let's look at number 20, and we're given either a sine or a cosine function in a table, and we need to find the period, midline, and amplitude. We're told that we're given the max and minimum values of the graph. So if we look at the period, we want to look for where our y values are going to repeat. So here I see a 9, and then I see another 9 here. So my period should be the difference in time there, so it should be 17 minus 5 should equal 12. So every 12 seconds, minutes, hours, whatever, our graph is going to repeat. Okay, and for our midline, we'll take our minimum value plus our maximum value and divide that by 2 to find where the middle is, kind of like taking the average of those 2 points. So I'll have 9 minus 1 over 2, or 9 plus or minus 1 over 2, that should give me 8 over 2, which is 4 for our midline. And then for our amplitude, we'll do something very similar, except we're going to subtract. So we'll take our maximum value and subtract our minimum value, and then divide that by 2. And so that should give me 10 over 2, or 5 for our amplitude. Okay, so we're given this graph, and we want to find the amplitude, period, midline, and whether it has a reflection or vertical shift, and write an equation for the graph. Okay, so for our amplitude, I think we'll do the same thing we did for the table. We'll take our 3 minus our minus 1, and then divide by 2. So we should get that our amplitude is 2. And then if we're considering a sine function, we can see that the peaks and valleys of the graph are kind of inverted to what they normally should be. That implies that there is a reflection across the x-axis. And then for our period, we can kind of look for where our graph begins to repeat. I like to kind of do it this way. And it looks like our graph reaches the same spot at around 2 pi. You can also do this by looking at the distance from peak to peak as well. Either of those will suffice, but either way it looks like our period is 2 pi. And then we can see our midline visually appears to be at around 1, but let's do some math to figure that out. So we'll do 3 plus or minus 1 over 2, and that should give us 2 over 2, which is in fact 1. Okay, great. Vertical shift, we certainly have been shifted up. Yeah, we've been shifted up 1. Our midline should normally be at 0, so we've been shifted up 1 unit. Okay, and according to all of this information, we should be able to write the equation of our graph, and we said earlier we were considering a sine function. So our amplitude is 2, and we had a reflection in the x-axis, so I should have a negative out front and a 2 out in front for my amplitude, and that'll be times sine, and then sine's period is normally 2 pi, so I don't have to do anything inside my parentheses, and lastly we are shifted up 1. And so there are also a million different equations that you could write. You could also do this in terms of cosine. You could use a phase shift. So if you got an answer that was different, it might also be correct. There are a million and one ways to do this problem. Okay, next we're given this function negative 4.2 sine of x plus 1.1, and we need to find a bunch of things for it. The amplitude is pretty nice. It's just given to us in the formula. It's just that 4.2. And then our midline, normally our midline for sine is located at 0, at y equals 0, and here we have a vertical shift of 1.1. So we can kind of think about shifting our midline up by 1.1. So our midline is now at 1.1, it used to be at 0. Okay, and then for our domain of any sine or cosine function should just be all real numbers, so negative infinity to positive infinity, and you kind of think about that graphically. It's never going to stop going as x approaches positive infinity or negative infinity. That graph's just going to keep on going. Okay, and then for our range, so consider the range of just negative 4.2 sine of x. We know this range would go from 4.2 to negative 4.2, where our midline is at 0. And so now we just need to think about shifting everything up by 1.1. So that's what we'll do. I'll just add 1.1 to both of these values, and that'll be my new range. So I'll now be at 5.3 and at negative 3.1, and where my midline is at 1.1 now. So that's what happened when we shifted it up. It also shifts our range. So our range is now from negative 3.1 all the way up to positive 5.3. Okay, so next we're going to look at number 23. We need to determine the amplitude, period, phase shift, and any vertical shifts in the graph. So I think our first step is we need to be able to tell what that b value is that determines our period. So I think our first step is to factor out a 2 from inside the parentheses there. So I'll say a 4. And so then I'll be left with x minus pi over 8. That's what I get when I divide pi over 2 by 4. And then still plus 1 on the outside. Okay, so then we know for our amplitude, it should just be that 3 out in front. Our period is given, we know that 2 pi over b is equivalent to our period. So where here our b is 4, so we'll go ahead and compute that. That'll be 2 pi over 4. That's the same as pi over 2, so that will be our period here. Okay, and then our phase shift, that'll just be any horizontal shifts. So we have a phase shift by pi over 8, and that'll be, since it's minus, it'll be towards the right. Okay, and then lastly, that plus 1 out here, that is a vertical shift of up 1, so 1 up. Perfect.